Today we're going to be dividing polynomials. The state standard that we need to know today is know and apply the factor theorem. Your success criteria, you need to be able to use long division to divide polynomials by another polynomial, divide polynomials by binomials of the form x minus k using synthetic division, and explain the remainder theorem. Vocabulary that you need to be aware of: polynomial long division is one way to divide polynomials and is called polynomial long division. There's some polynomials you'll see that you can only use long division for, so that's why we call it polynomial long division. You also learn synthetic division, but those can only be used in special cases. All right, synthetic division is a shortcut for dividing polynomials by binomials if they're in the form x minus k. So if you have a binomial x minus k in this form, you will be able to use synthetic division. It's kind of a shortcut. Example 1, using polynomial long division. All right, so hopefully you remember from 4th grade when you did long division with just numbers. The process is going to be very similar with polynomials. The difference is polynomials now has variables, exponents, and all that fun stuff. So let's get started. It says divide 3x cubed plus 5x minus 1 by x squared plus 3x plus 2. So we're going to set it up just like regular long division. So we've got x squared plus 3x plus 2. And we're going to divide that by 3x cubed plus 5x. All right, so what I notice here is there's no x squared term, so we do need to put a placeholder here. So we're going to put plus 0x squared, then plus 5x minus 1. And you'll see shortly why we need that placeholder, so that we don't lose a position or try to add terms that cannot be added together. We're going to start with the first term, x squared, and we're going to say how many times does x squared go into 3x cubed? Remember, dividing is the inverse of multiplication, so you can think what times x squared gives me 3x cubed, and that would be 3x. Then we're going to turn around and we're going to multiply 3x times x squared, 3x times 3x, and 3x times 2, and then we're going to put that here. Then we're going to subtract this row from the row above it, and that shows that we have divided the first part out. So 3x times x squared is 3x cubed. You always want the first column to be the same, because I'm going to subtract this from this, and that'll make that one go away for the next row. So we've got 3x times x squared is 3x cubed. 3x times 3x is 9x squared. And we're going to put that under the 0x squared so we don't lose it. 3x times 2 is 6x. Now, just like regular long division in 4th grade, we subtract this one from the one above it. Now, when I say subtract, that means every term in that row. So again, just like when we added and subtracted polynomials, if you want to change the sign here, that'll keep you from losing a negative. 3x cubed minus 3x cubed cancels. 0 plus negative 9x squared, negative 9x squared. 5 plus negative 6, 5 plus negative 6 is negative 1, and then always bring down your last term as well. All right, that's kind of hard to read. Let's see if I can fix this 9 here. All right, now we go to the next term. How many times does x squared go into negative 9x squared? So we're doing the same process again. We're starting over. We're looking at this term right here. X squared goes into negative 9x squared negative 9 times. So we're going to put a negative 9 there. And then we have to multiply it again by each of the terms here in the divisor. So we're going to have negative 9 times x squared is negative 9x squared. Negative 9 times 3x is negative 27x, and negative 9 times 2 is negative 18. All right, we're going to do the same process as we did before. We're going to take this whole row here and subtract it. And in order to do that, we're going to change the signs and add. So I'm going to distribute this negative. So I'm going to make this a plus, minus a negative, minus a negative, minus a negative makes each of those a positive this time. All right, now we have negative 9x squared plus 9x squared. That's going to cancel. Negative 1, remember that's a coefficient of 1 if there's no number there. So negative 1 plus 27 is 26x. Negative 1 plus 18 is plus 17. Now we're going to try to do it again. X squared into 26x. Since you cannot divide x squared into an x term, that means the rest of this is the remainder. So you've got 3x minus 9, and then the remainder is going to be 26x plus 17, and it's going to be over this right here. So x squared plus 3x plus 2 is the remainder. And you can see it says common error when there is a remainder. Add the expression r of x, that's your remainder, over your divisor, d of x, not just r of x. So don't just put 26x plus 17. You have to put 26x plus 17 over this right here. So 3x minus 9, remainder, 26x plus 17 would be your final answer. Make sure you have taken notes. I'm going to erase this so I have room to do the next one in just a second. All right, let's look at another example here using long division. So we've got 2x squared minus 5x minus 3 divided by x minus 3. So I'm going to have x minus 3 divided into 2x squared minus 5x minus 3. Again, we're going to look at the x and say how many times does x divide into 2x squared? That would be 2x times. It's similar to factoring, and again, 2x times x should equal 2x squared, so division is the inverse operation of multiplication. So if you can multiply that and it comes out to be your first term, you know you've at least started correctly. So 2x times x is 2x squared. And then you're going to do 2x times the negative 3. So that would be negative 6x. Since we're dividing this out of this expression, each time we have to subtract. So I'm going to subtract 2x squared is a negative 2x. If I subtract a negative 6x, that becomes positive. So this cancels. Negative 5 plus 6 is x. And then bring down my negative 3. X goes into x one time. You do need a placeholder for that. So we're going to have 1 times x is x. 1 times negative 3 is negative 3. I'm going to subtract. Subtract a negative makes that a positive. This cancels, and that means your remainder is 0 for that one. Something we will talk about a little bit later is if you get a remainder of 0, that means this expression, this binomial here, is a factor of this polynomial. And again, this would be a factor as well since you have a remainder of 0. So basically, if you want to check this, again, division is the inverse operation of multiplication. If you do x minus 3 times 2x plus 1, you're going to get this expression here. So x minus 3 times 2x plus 1, multiply the two binomials, and you will get what you started with. This is a topic that sometimes is a little challenging for students, so I want to stop right now while we've just done a couple examples and do a self-assessment. So I want you to practice doing long division on your own. So you're going to divide x cubed minus x squared minus 2x plus 8 by x minus 1. If you do that, then try this one as well. This one should be a x squared term here. Let's see if I can get that fixed. Okay, that's an x squared. All right, go ahead and try those on your own. I'll be back in just a moment to see how you did. All right, I hope you took a few minutes to see if you could do this on your own. All right, if you divide these two polynomials, you should get x squared minus 2, and this one has a remainder of 6 over x minus 1. The second one, when you divide, you're going to get x plus 3 with the remainder of 2x plus 2 over x squared minus x plus 1. Hopefully you remembered to add the 0 placeholder when one of the terms was missing. So this one had x cubed plus 2x squared. It did not have a linear term or an x term, so we had to add 0x and then plus 5. And the reason we did that is because you have to have each degree in order to add or subtract common terms. You can't add an x squared with an x or an x cubed with an x squared or an x. So that's why you add that placeholder, is so that you put each column will add up with like terms.